Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain the topic, that is modern periodic table. Modern periodic table, before that I have explained in part 3 old form of periodic table, that is by Mendeleev, and also the modern periodic table also by Mendeleev. But what is the difference between two tables? The old form periodic table, that is based on atomic mass, and here the new form, that is modern form of periodic table, that is depending on in the order of atomic number. What is atomic number? Atomic number means number of protons and number of neutrons in the nucleus. Now see, after discovery of atomic number, which is the fundamental property, after discovery of atomic number, and now atomic number is the fundamental property of the atom, that is property of elements. What is atomic number? I told, number of proton plus number of neutrons in the nucleus of an atom. Mendeleev periodic law also modified. What is the old form of periodic law? That is properties of elements are a periodic function of their atomic weight. Instead of atomic weight, here it is known as atomic number. Here it is basing on atomic number. Here the elements are arranged in the order of increasing order of atomic number. So what is the Mendeleev, that is new form or modern form of periodic law? That is properties of elements are periodic function of their atomic number. That means when the atoms are arranged according to the atomic number, it is observed that the properties also following periodic function. Periodic function means after some elements, again the property that is similar to the first. So atomic number is the number of proton and neutrons in the nucleus. So elements are arranged according to the increasing order of atomic number. Order of increasing atomic number means let hydrogen 1 atomic number, then helium 2, after helium that is lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, like this. It is increasing order of atomic number, the elements arranged. Now how many that columns, how many horizontals are there? There are 18 vertical columns are there where the elements are that is present in the column, that is called group. Similarly, there are 7 horizontal rows, that is called period. So vertical column is like this, and that is called column, and 7 horizontal row, this is called row, that is period. Are you clear? If you see this way, this is column, that is group. If you this way, that is horizontal row, that is called period, it is called groups. So here it is groups, and here it is period. And now how many period? How many? 7 horizontal rows, that is called period. How many column? 18 vertical column, that is groups. Are you clear? What is modern periodic law? That means properties of elements are periodic function of their atomic number. Here you see what are the properties of period. Properties of period mean in a period, but how many periods I told? 7 periods. Why? Because there are 7 horizontal rows. In a period, the elements do not have the same number of valency electron, because the elements are arranged according to their atomic number, increasing order of atomic number. That is why they never shows the same number of valence electrons. It is only possible in a group, but in a period the valence electrons are different. They contain the same number of cells. They contain same number of cells. I want to say about the cell. The cells are known as K, L, M, N, like this. K, L, M, N. In higher class you will read very well about this. The number of valence shell electron increases by 1 unit. Why increases by 1 unit? Because here atomic number increases 1 by 1 unit in a periodic table. So valence electron also increases by 1 unit. Then the atomic number increases by 1 unit, that is from left to right. The period starts from left to right. So, see here, in a particular shell different elements are placed. Now particular period, in a particular period different elements are placed. Particular period, suppose first hydrogen, helium, and second lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now, so these are the periods only necessary for class 10th up to 3 and 4 period, only 2 elements you should remember. In higher class when you go, you will read up to 7th period, how there are so many divisions are there, how to read and how to remember all the things. But here first pair contain hydrogen, helium, 1 is the atomic number, 2 is the atomic number of helium, 1 is the atomic number of hydrogen. Similarly, second period lithium, beryllium, see this is the atomic number 3, 4, 5, that means increases by 1 unit. Why? Because atomic number increases by 1 unit. So valence electron also increases by 1 unit. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now third period sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, 1 by 1 unit. See again, sodium is 11, magnesium is 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17 and argon is 18. Now here fourth period only 2 you remember, potassium 19 and calcium 20. These are the atomic numbers. Now see 1, 2, 3, 4, 5 up to 20 it is there. You should remember up to 20 in 10th class. In 11th class you will read almost all the periodic elements in different groups and different periods. Now we will see what are the configuration. For configuration, what you want, what you should you know about the configuration. You can do configuration easily, and after that we will see different properties of that is here elements in the periodic table. Again see periods mean here there are 7 periods, 7 that is horizontal rows. In a period the element do not have the same number of valence electron, that means valence electron increases 1 by 1 as atomic number increases 1 by 1, and the particular period different element can be placed, and that is atomic number increases by 1 unit. The first period hydrogen, helium, all are arranged according to their atomic number. Second period contain lithium, beryllium that may come to boron, carbon, nitrogen, oxygen, fluorine, neon. Third period sodium, after sodium see it is 11, then magnesium is 12. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, then chlorine, then come to argon. So these are the periodic elements you should remember, and I hope next coming video I will explain the configuration of elements. Then here I hope it is clear to you, and hope you will subscribe my channel B.L.DASH Short and Sweet in Chemistry. Thanks for watching my video. Thanks again to all. Now we will see here what is meant by group here. What are the main characteristics of group? Now groups of all elements, that means in a group what elements present, they contain same number of valency electron. What is valence electron? The outer shell which contain, suppose this is the nucleus, this is the cell, and now here the cell, outer shell contain, let here group 1 contain 1 electron, that means here you see this group 1 hydrogen group 1, and now what happened, group 1 contain always 1 electron in the outermost shell. We will see in configuration how the outer shell contains same number of electrons. The element present in any group, suppose first group, second group, 13 group, what happened? Number of valence electron contain same number of electron. Number of electrons, that is outer shell, contain same number of electron. So the elements present in a group contain same electron, or you can say any group that always contain same number of electron, the number of valence electron same. The groups in the periodic table have identical configuration. Here when you see the configuration, at that time you will know how the configuration same, identical configuration same. That means hydrogen 1, lithium 2, 1. When you go to higher class you will see 1s2, 2s1 like this. But here SPDF not required in 10th class. Lithium 2, 1 and sodium 2, 8, 1. See, outer shell contain only that is 1 electron here, outer shell. Potassium 19, that is 2, 8, 8, 1. But here rubidium, strontium, francium, this cannot be explained by the simple method. That is why you should learn an SPDF in 11th class, so that after that you can write the configuration of the higher atomic number elements. The number of cells increases as you go down the group. Number of cells. Suppose here 2 cells, this is 1 cell, is 1 cell. When you go down the group, here you will see this cell increases, here 2, here 1, like this cell will increases. So in group 1, sorry, you can't explain here 2 cell. Group 1, that is I want to explain, this is hydrogen. It is hydrogen. Similarly, if you see other elements also contain same 1 electron in our outer shell. Now you can see, remember group 1, 2, 13, 14 and 15, 16, 17, 18, like this you should remember, and middle of this from 3 to 12 not required to remember now. These groups sufficient to remember all the elements. Suppose one asks, what is group 1 element? How can you say hydrogen, lithium, sodium, potassium, rubidium, cesium, francium? Like this you should remember. And what are the atomic number? I have explained here: 1, 3, 3, 11, 19, 37, 55, 87. So gradually you can remember all the atomic number, or anyhow try to remember the atomic number one by one and in increasing way. Now second group, similarly beryllium, magnesium, calcium, strontium, barium, radium. And like this you should remember with the atomic number. But first of all you should remember the elements present in group. That is most important in our chemistry. 13 group means boron, aluminium, gallium, indium, thallium. See 5, 13, 31, 49, 81. And next is 14 group. 14 group means starting from carbon, silicon, germanium, tin, lead. Tin, that is English name, actually in chemistry in Greek that is one SN, stannum. What is SN? Stannum. In chemistry what is that one? Stannum. And in English tin, and in English it is famous tin, that is why SN, stannum. 50. Plumbum, PB, plumbum, in English that is lead. So here also lead is famous, and you should know what is PB is plumbum. Then come to 15 group elements. Similarly, starting from the nitrogen, phosphorus, arsenic, antimony, bismuth. How remember? Nitrogen, phosphorus, arsenic, antimony, bismuth. Here also important. Antimony, that is English that one, but in English, but in chemistry that is stibbium. SB means stibbium. Remember, stibbium, bismuth means Bi. Then come to 16 group, an element that is started from the second period, and here this is 0, 8 minute. Remember, that is mean here starting from oxygen, sulfur, selenium, tellurium, polonium, oxygen, sulfur, selenium, tellurium, polonium. Similarly, 17 group, fluorine is starting, fluorine, chlorine, bromine, iodine, astatine. And here this is neon. 18 group mean 0 element, 0 inert gas, inactive, neon, argon, krypton, xenon, radon. And here you can say 17 group, these are called halogen group. Halogen group mean that is these are available in sea. So these salts are available in the sea, that is why halogen, halo produce, gen mean produce. And so here this is called alkali, this is called alkali, you can write this alkali and it is alka. If you are interested then you can remember, otherwise not necessary for class 10th and 13 group, 14, 15, 16, this is called halogen and that is called 0. And you can find here, if you write in the same way, this is group 1, period, sorry, period, what is period here? 1, it is period 2, it is period 3, period 3, 4, 5, 6, 7. See, there are 7 horizontal rows I told before. Here also you can find there are 7 periods. First period, second and third period, and up to here calcium you should remember. Are you clear? Up to calcium you should remember 10th class. How can you remember? What are the elements in period 1? Hydrogen. In second period starting. Now you can see one by one atomic number increases. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You can find 3, 4, 5, 6, 7, 8, 9, 10. Lithium, beryllium, boron, carbon, nitrogen, oxygen. Next last to fluorine, next neon. Neon is the 0 group. 0 group means the inert elements, inactive elements. Actually it is called 18 group. 0, why it is told? Because it is valence is 0, that is why generally told 0 group. Now third period, sodium 11, magnesium 12, aluminum 13. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. What is the last one? Argon. Again see, potassium 19 and end with 18. So that is third period. Sodium is 11, magnesium 12. 11 starting ending with 18. Again sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So and now fourth group you should remember up to calcium, and others you leave it. And but here in period also you can find these are the elements. So other period that is good for higher class, because here so many things, new things you will learn, and you can know what are the elements in the 4th, 5th, 6th, 7th period. Only remember group 1, 2, 13, 14, 15, 16, 17, 18. So what are the elements of 18 group? Can you say? You start from neon, argon, krypton, xenon. Sorry, I forget to write here helium. Sorry, it is helium. Helium is 2. Again please, sorry, and here you observe 18 groups started with helium. Helium, neon, argon, krypton, xenon, radon. Similarly, halogen, suppose one can ask, what is the halogen group? That is 17 group. What are the elements? Fluorine, chlorine, bromine, iodine, astatine. Similarly, 16 group, oxygen, sulfur, selenium, tellurium, polonium. Like this you can say any group elements with atom. It is better if you remember atom number. Otherwise few atom number, what you should learn, what you can learn, that you remember. Otherwise in high class you will learn all the atomic number. So how many groups are there? 18 groups. How many periods there? 7 periods. Now we will see that other properties of group, period, and atomic number, atomic size, atomic mass, isotope, all the things will be clear.